This conference will now be recorded.
Okay, students, let us start today's session. So, in our last class, we have learned how to develop the code for creating the binary tree set. Now, today we will develop the algorithm and the coding for the traversal of that binary tree. Let me show you. Yes. So, representation of binary tree, we have seen that how to represent the binary tree is one is approach is array approach, and another approach is the linked list approach. Now, how many traversal we have seen? We have seen three traversal. What are the three traversal? One is called pre-order traversal, one is called in-order traversal, and another is called post-order traversal. There, all the traversal technique we have seen theoretically. English language word we have used there to write that traversal algorithms. Now today I'm going to show you what is the algorithm, in which algorithm means, of course, whenever we are talking about algorithm, till now most of the cases we have followed that C like approaches for writing the algorithm. Similarly here, to develop the algorithm for pre-order, post-order, and what is called in order, we will take the approach of C like approaches, so that when the function will come, we will very easily develop the function. Observe here, write an algorithm, recursive algorithm, because both version we are going to learn. Write an recursive algorithm for pre-order traversal. Write a recursive algorithm for pre-order traversal. Pre-order traversal. So I hope you remember that to write the algorithm, we must have five properties: input, output, finiteness, effectiveness, and definiteness. Normally, what style we follow? So we write input and output. Now, whenever we are performing any pre-order traversal, we are not going to take anything as input, because already the tree itself is acting as the input for me. What is the input? For this traversal, we are not going to take any explicit input. The tree itself is acting as the input, because we are going to traverse where? In the tree. And when that input is taken at the time of tree creation, for traversal we are not going to take any such input explicitly. And you remember, guys, in that algorithm properties input output, in input we said that input can be 0 or any number of input. That means in some algorithm we can have 0 number of input also. So for the traversal, no input, sir. Where is the input? At the time of creating the tree, there we have taken the input, here no input. So output only is, output is what? Output means what? If you are performing pre-order traversal, after pre-order traversal, that is the output. That means the traversed tree, the traversed tree in pre-order, the traversed tree in pre-order, that is the output, sir. Now you know that, sir, definitely I need the tree to be represented before I can make traversal. You see here we made the traversal now, guys. But is this how we are going to implement? Is this how we are going to represent the tree? No, 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 sir. We are going to represent the tree in this fashion. We are going to represent the tree in this fashion. We are going to represent the tree in this fashion. Then we are going to make the traversal, sir. Using linked list, we are going to represent the tree, and then we are going to make the traversal. 1 minute, students. Yes, come back. So now, sir, how can I develop the algorithm for this tree, sir? Observe carefully. The very first activity that I know that I need here, that I definitely need to provide the definition of the node, which you are already familiar, because we have created the tree now, sir. There we have taken the node definition. Let me copy it from there. This is my node definition. This is my node definition, because without a node definition I cannot write the algorithm, right? So let me provide this as a remark. I'm giving you remark here. Remark. What is that? Consider the following structured definition. Consider the following structured definition of a node. This is what we have taken as a definition of the node while the tree is constructed, sir. Next, and after that, another very important point throughout the coding we followed, that is what, sir? We declared that root node as a global variable, or better to say, consider the following structured definition of a node. Actually, this definition we have taken locally in a global in a structured definition of a node, which is declared globally. Our node structure definition in the coding was taken globally, sir. Let's say which is declared globally. Next, how to develop the algorithm? Very simple, guys. Sir, algorithm. What is the name? Pre-order. Name of the algorithm is what? Pre-order. Algorithm pre-order. Tell me, students, once the tree is constructed, yesterday you have seen that, sir, our tree got constructed. Once the tree is constructed, you remember in case of single linked list, guys, once a single linked list is constructed, if you have to hand over the single linked list to anyone, by capturing which node you will hand over the single linked list? Sir, definitely start. Similarly, whenever you will hand over this tree to anyone, suppose you want to give this tree to someone, which node you will capture to give it to someone? Are you going to take temp to give the entire tree? No. Are you going to take parent to give it to someone? No. Then which pointer you will capture to give it to someone? Sir, that will be root. I will be giving root to hand over the tree to anyone. That is what I will pass. Similarly here, whenever I will write this pre-order function, I will pass root as the argument. I will definitely pass root as the argument. Next and after that, while calling the function, I will pass root. Let me do that. While calling the function, from where we will call case 2. Case 2 will be for what? Pre-order. What I will pass? Root. Similarly, case 3 will be what? Sir, in order. What I will pass? Root. Case 4 will be what? Post order. What I will pass? Root. Post order. What I will pass? Root. So one by one. First, let me define the pre-order. This is my pre-order function, sir. Pre-order. I'm passing root. So what is the type of root? Struct node star, that I'm capturing in a variable ptr. Struct node star. And let us assume I don't want to return anything, so my return type will be void. So in the pre-order function, suppose it may happen, guys, when you driven program, na, so when you run the program, it may happen sometime programmer or user can directly give option number 2 without creating the tree. He is giving option number 2. So tree is not there, then what will be the traversal? Okay, then what is the root value at that time? If the tree is not created, what is the root value at that time? Sir, null. So that means when you pass this to pre-order function, what value will pass? Null. Pre-order will capture what? Null. If pre-order is capturing null, what to do? Nothing to do. Or if tree is null, how I will traverse, sir? So when you will traverse, if my PTR value, whatever I am receiving, if it is not equal to null, then only I can traverse, sir. Achha, if it is null, are nothing to do. If it is not null, then something to do. If it is not null, nothing to do. Sorry, if it is not null, then something to do. If it is null, nothing to do, sir. That's why I'm writing PTR not equal to null. If PTR not equal to null, then only I'm going to do something. If PTR is equal to null, it will not enter, function terminated, everything got terminated. Nothing to do, sir. Now, if it is not null, that means some nodes are there. Then what I will do, sir? Already we know the English version. Here it will be PTR. Here it will be PTR. PTR. Now listen. Here what I will do, sir, when I will start my activity, if PTR is not equal to null, then I will start my activity. Okay. So what activity? Let me do one thing. Let me bring that English language algorithm into your visibility area so that by reading those things, we can develop the algorithm. Yeah. Series. So PTR not is equal to null. What is the first step, sir? Visit the root. Visit the root means actually what? That data part I am asking, they're asking me to visit. Visit the root means they're asking me to visit the data part. Otherwise, what I will print? The data part only I will print. Nah? So visit the root means visit the root's data part. So what I'm writing here, right? Root is now captured in where? PTR. Then what I will say? PTR arrow data. Right? PTR arrow data. Same thing when I will go for coding, what I will do, sir? Here the same line will be replaced with what? Printf percentile D PTR arrow data. Printf percentile D PTR arrow data. Array. Printf percentile D PTR arrow data. Done. Next and after that, sir, what is the next thing? Traverse the left subtree pre-order. Think, guys, you are developing pre-order function and there you are again using the word pre-order. What does it mean? Oh, recursive function call, sir. Recursive function call pre-order. But with what? Left subtree. Na? Left subtree, how will go? Sir, PTR arrow L child. PTR arrow L child. I will get the left subtree. Then, sir, another time right subtree, na? Pre-order. PTR arrow or child. Story and sir. Algorithm finished. Implementation done. Coding also done. Oh, this much simple. This is this, sir? Yes. Sir, can you please explain? Yesterday you explained. Yesterday, no, day before yesterday you explained, na, sir. Pre-order, in-order, post-order. By traversing the tree only once. I understood. Sir, can you please explain once by showing this recursive function internally how it works, how the tree will be traversed, sir? Internally how it will work? Can you show once? Yes, I will show. I will definitely show. Before that, let me write the coding here also. What will be the coding, sir? Pre-order PTR arrow L child. Next, pre-order PTR arrow R child. Acha, tell me, students, I have given you one task. I ask you for that tree what is the pre-order traversal, you have to calculate, right? Hope you have done. Please paste it in the chat box for this tree. Where? Yes, for this tree, sir. Yes, this is the tree, guys. Paste the value once in the chat box. What is the pre-order traversal for this one? I will take all of them, pre-order, in-order, and post-order. First you paste the pre-order traversal, because if you paste it, then only I will able to match the output with your answer. In the meantime, you paste. Let me in the meantime take the tree, sir. Acha, okay, already I got the answer. So first let me take the tree, execute, compile and run. So 1 minute, I made one mistake here. What is that mistake, sir? 1 minute. While printing, percentage slash t would be better. Pre, here one spelling mistake is there. Pre-order. Next. Hash include, one mistake is there. I hope remaining things are okay. Execute, compile and run. Okay, here still one mistake. Temp arrow data is equal to num. What is that? So before that, choice. What is the mistake? CHOICE. The choice is not declared. Choice. Okay. Num undeclared. Let me declare. So num undeclared. Num I have declared na. Num. Anywhere else num. Yes, here num. Here num. Here how I am getting that num value, guys? Temp arrow data is equal to num. Not num, sir. It is actually item, na, guys. It is actually item. Okay, sir. Yeah. Okay. Yes, I will verify that. Execute, compile and run. Any error, any warning? So here, in order, post order. Okay. Those functions calls I have done means I have to define those function. No problem. Just I'm writing empty body void in order, because I called them na. So I have to define them. Otherwise, I have to comment those part, or I have to define here a empty body. Next, void post order struct node star ptr. Done, sir. Execute, compile and run. No error, no warning. Oi. What is this, sir? Somehow it is in infinite loop. Control pause break. Control X, Control Z. Yeah. Where is this infinite loop, sir? While one. Enter your choice. I need to take a value now, guys. Scanf %d ampersand choice. Execute, compile and run. Still not satisfied, sir. New line I am expecting. Create the binary tree /n /n. Okay. Execute, compile and run. Super. Oh, still not done. Enter your choice. execute, compile and run. Okay, enter your choice 1. This time I have to give that value, that order. Yes, 50, 1, 30, 1, 60, 1, 22, 1, 38, 1, 55, 1, 34. Tree ready? But how can I see that tree, sir? Only option is, it's not like single linked list display. You will display the tree. You will not able to display the tree. How you will display the tree, guys? If you try to say that, sir, I want to see that tree is there or not, how you will display? This tree is there, how you will display? Which part you will display first? Not possible. That means only option is left. What? Sir, I have to go for traversal to make sure the tree is perfect or not. So enter your choice 2. Now your result, check it out, your result, guys. 50, 30, 22, 38, 34, 60, 55. Super. Done, sir. Pre-order traversal is done. Achha, only one thing I have to do. Second time it is not coming in the same, it's coming in the same line. Let me give a slash in here. Okay, we will run one more time. No need to worry. But before that, let me very quickly complete the remaining 2 traversal also. Then we will understand how it is going to work, sir. Recursive function we will understand. Where it is, sir? Yes. Acha, before, because remaining 2 are also very, very easy. It will not take more than 5 minutes to write the code for remaining 2. Next activity, sir, we want to understand this code. How recursively it will work. Okay. To understand how it is going to work, I need a small tree, guys, not too much big tree. Because if I take big tree, that many recursive call is there. So it will take a lot of time to give you the clarity. So simple tree I will take here to give you the clarity. Not this much node, guys. Not this much node. Delete, delete. A, B, E. Okay, let me delete this one also. Okay, this is the tree, sir. You can take any tree, guys. Any tree you can take. So this is not even done, because if I write in this way, I cannot able to give you the clarity. So what I need, sir, I need linked list representation to give you the clarity. I definitely need linked list representation to give you the clarity. Acha. First of all, A, B, C, E. Acha, this fellow not required. Next. Okay. Remaining things are done. Just the change of the values here. Just arbitrarily, totally arbitrarily taken this tree, guys. You can go on and practice on any tree, sir. Here it is. A, B, C, So this is D. Let me take it as D. Next, every node must have some address, sir. That will be 100, 200, 300, 400. Acha. Before I complete this tree pre-order traversal, student, you complete the traversal. When I will ask you, you will tell me the answer. Okay? Just for this tree, you complete the traversal, but don't type in the chat box. Hope you have done it. Next, this is the algorithm. I need this thing into your visibility area. Okay. Later I will remove that. Just for to keep it in your visibility area, I kept it there. Now recursion means what, sir? 100% stack will come into the picture. So many stack application you did, guys. So many stack application you did. One more time. Oh, this is another application of stack, na? Definitely another application of stack. So when the function will execute, the very first instance that will be kept inside the stack is main function. First instance that will be kept in the stack is main function. Let us assume this is the instance for main function, sir. This is the instance for main function. Then from the body of the main function, guys, from the body of the main function, what happened is that we called pre-order function. At which line number, sir? 68 line number. We call the pre-order function at line number 68. Remember that story? I told you to revise that recursion concept. One concept is there, na? Instruction pointer. Instruction pointer for main method will remember that once the control will come back, I will start my execution from line number 69. I will start my execution from line number 69, something like that. Now what will happen? Control will go to the pre-order function. In pre-order function, I have line numbers, sir. 1, 2, 3, 4. These are my line numbers in the pre-order function. Now when you call the pre-order function, what you are sending? Sir, I'm sending root. What is the address of root? 100. That 100 is captured where? In the PTR. This is my pre-order function, sir. This is my pre-order function. This is the PTR value. What is the PTR value? What is the PTR value for this pre-order function? Sir, 100. PTR value is 100, sir. Great. Automatically you are checking what? Is this PTR is not equal to null? Yes, true. Write PTR arrow data. What will be printed, guys? A. Pre-order traversal. Pre-order traversal. What you are going to get in the output? A. Excellent. Then line number 3 is a function call to itself. Oh, that means, sir, from here another pre-order function will be called, na? Another pre-order function will be called. So line number for this pre-order function, sorry, instruction pointer for this pre-order function will remember when the control will come back, I will start execution from line number 4. Currently, where is the function, sir? Where is the control? Sir, I was executing this pre-order function. He suddenly called pre-order of ptr arrow L child. Ptr is what? 100. 100 arrow L child is what? 200. So that means this pre-order function calls another pre-order function. This calls another pre-order function with what value, sir? With what value? Sir, definitely with the value 200. Definitely with the value 200. So that means current PTR value is what? 200. Function starts working, checking that is this PTR is not equal to null? Yes, null. Not equal to null. Write PTR arrow data. 200 arrow data, sir, B. 200 arrow data, sir, B. Super. Next. Sir, done. Next line. Pre-order of PTR arrow L child. Oh, again function call, sir. Again function call. Again function call. What is that, sir? PTR arrow L child. But instruction pointer will remember what for this also? 4. What you called? PTR arrow L child. Currently PTR is what? 200. 200 arrow L child is what? This node arrow L child. Oh, null. That means, sir, pre-order function called pre-order of PTR is called with what value? Null. With what value, sir? Null. This PTR value will become null. What is the pre-order value? PTR value null. Control comes here. If PTR not equal to null, no, equal to null. If block will entertained, no. End of if, end of function. That means this fellow is done. This instance is done. Super. This instance is done means set removed from the stack. This is removed from the stack. What will happen? Sir, control will come back to the previous instance. In previous instance, which line number pending? Pre-order of PTR arrow R child. Pre-order of PTR arrow R child means 200 arrow R child, sir, it's 400. That means here pre-order function called with PTR. What is the value of PTR? What is the value of PTR? Sir, the value of PTR is 400. The value of PTR is 400. PTR is 400. Immediately, once this line is called now, so let me make this one also a numbering, line number 5, and this is what? Line number 6. Now this time, sir, when PTR arrow R child is called as line number 4, instruction pointer immediately says that okay, you call that PTR arrow R child, but when the control will come back now, when the control will come back, I will start execution from line number 5. I will start execution from line number 5. So let me move it from here. The stack is growing like anything, guys. Stack is growing like anything. No problem. No problem, sir. Okay, sir. So PTR of 400. PTR of 400. Is it not equal to null? Yes. Enter. Write PTR arrow data. What will be printed, sir? Sir, D will be printed. D will be printed. Done. Next, PTR arrow L child. Oh, sir, null. But you are not, you have to call that, na? It will not work, but you have to make that calling. Pre-order of PTR again. What is this value? Sir, PTR value is received as null. Instruction pointer for this fellow will remember what? Sir, instruction pointer for this fellow will remember line number 4. Line number 4. Super. Control goes there. Sir, it's a null. Null to? Sir, function will not execute. Yes, correct. When the function body will execute, if it is not null, but currently it's null, sir, then how it will execute? It will not execute. Okay, it will not execute means, sir, this instance is not making any function call. So you can happily remove this instance from the stack. That means making a pop operation. That means making a pop operation. Immediately control will come back. Control will say, now my job is to execute from line number 4. What is that? PTR arrow R child. Check it out. 400, you are currently here. PTR arrow R child means again null. Again null means, sir, again it will be called. That means this time it is expecting when the control will come back, control should start from 5. So again, which instance will be created, sir? Pre-order of PTR and PTR is equal to null. So explicitly I'm not writing here again and showing you because unnecessary space will be wasted. So that means same thing will happen. Same thing will happen and it will come back. Where? Line number 5. Line number 5 means it is done, sir. Line number 5 means ending. This fellow is ending. That means, sir, this is also done. This fellow is also ending now. Then where the control will come back? Previous already done. Previous, yeah, 200 here. Here which line to execute? Line number 5. Oh, this is also done, sir. Line number 5 means this is also done. This is also done. Next, sir, it will be come back to here 100, na? Which line to execute? 4. Pre-order of PTR arrow R child. Go to 100. PTR arrow R child means, oh, sir, 300. Let me do that. How I will write, sir? Can I know? So let me, where I can move this algorithm, guys. If I keep it here or not here. Somehow at the end. The thing is that whether you are understanding or not, or even I can move this fellow a little bit towards the left. Oh, this is also not possible. 1 minute. Can I move this fellow a little bit left? Now can I take the algorithm there? Can I see? No. 1 minute, guys. Okay, now we can see. Yes. So where we came back, sir? 100. There which line number is pending? 4. So that means 4 means pre-order of PTR arrow R child. So PTR is 100. Arrow R child means 300. Okay. That means again the function is called, this time what? Remember, this part was called for 2 times. I didn't show that, but this instance is for 2 times, right? Okay. Pre-order of PTR, sir. Then what value is received? 300 is received. PTR value is received as 300. Super. PTR is equal to 300. This fellow will start working. Then immediately what it will be checked? What it is going to check? The PTR value. Is it not null, sir? You check it. Is it not null or null? Not null, no, not null. Write PTR arrow data. Oh, 300 arrow data. What is that? C, sir. C. C. Super. Next. Sir, line number 4. Oh, that means what? Instruction pointer, sir. For this, we'll remember what? We'll remember what? Line number 4. In the meantime, you called from here, na, line number 4. That means instruction pointer for this fellow will remember what? Sir, line number 5. Great. Now you started again calling the pre-order function. This time PTR is what? 300. 300 arrow L child. 300 arrow L child you are calling. That means what value you are giving? Oh, null. PTR value is null, sir. PTR value is null. If it is null, will it enter? No, it will not enter. If it is not enter, what will happen? Sir, the instance will be removed from the stack. The instance will be removed from the stack. Let me do that. Remove the instance from the stack. Next. Sir, control will come to previous instance. Previous instance, which line is pending? 4. What is that? PTR arrow R child. That means 300. Oh, that is also null. Oh, that means same thing will happen. I'm not drawing it again. Same thing. I'm writing here 2 means it is for 2 times. Okay. So in this case, it will remember that once the control will come back, I will start execution from line number 5. I will start execution from line number 5. Okay, line number 5 is what, sir? Only second bracket close. That means what? Will be done and finished. Okay, done, finished. Sir, then here, what is that line number 5? Or line number 5 is nothing. Done, finished. Control will come back to main, na? Yes. Line number 69. Let's go there. Oh, break. Out of the switch. Out of the switch. Again, the menu will reappear. In the meantime, guys, I ask you one thing now, to give me the pre-order traversal of this one. Tell me. This is my answer. Is my answer and your answer is same, guys? Is my answer of pre-order traversal and your answer of pre-order traversal same? Respond once in the chat box. Same now? Now you understood how this pre-order traversal internally works, guys? Using your old knowledge of recursive function, using your old knowledge of what is called linked list, sir, everything is done. This part is not anymore required because already I've given the algorithm for you. This is just to give you the step by step explanation. And remember, This is my root, sir. When the tree was handed over, this is the root. The root value I captured in PTR. Isn't it, guys? The root value I captured in PTR to start my working. Done, sir. Once pre-order clarity I provide, na, in order and post-order clarity no need to provide, sir. In order and post-order no need to provide. Why? Sir, now from that English language I will write the code for in order and traversal. Really? Huh, sir? Really? What is there? Nothing. Okay. Then write. This is in order, na, sir. Go there. This is pre-order, sir. Exactly copy paste. Copy paste the if block. Right here, sir. In order, visit the left subtree first. That means this part will be coming first. Name of the function will be changed, sir. Pre to in. Remaining same thing, na? Remaining thing will be same. Yes, sir. Post order also do that, sir. If block only. Done, sir. Here it will not be there. Sir, there it will be printed at the end. Value will be printed at the end. So first it will be there, left part, then right part, then data part. Change the name of the function, sir. Post order. Done, sir. Tell me, students, earlier you said na pre-order traversal of that particular tree. Now type once in the chat box for that post order also, in order and post order also. Type once in the chat box. Type once in the chat box for this one, in order and post order, so that I can verify. Execute, compile and run. Okay. This is what Dia, in order or post order? In order. Okay. Then go for post also. Let me in the meantime you write post. In the meantime, I'm taking the values. Enter your choice, 1, sir. 50. Enter your choice. Enter your choice, 1. 50 done, 30. Enter your choice, 1. 60. Enter your choice, 1. 22. Enter your choice, 1. 38. Enter your choice, 1. 55. Enter your choice, 1. 34. Enter your choice, pre-order. Achha, pre-order 50, 30, 22, 38, 34, 60, 55. Okay. Next, enter your choice, in order. In order, check it out. 22, 30, 34, 38, 50, 55, 60. Last, fourth. Post order. 22, 34, 38, 30, 55, 60, 50. Super na, boss. Guys, enjoyed na the coding of trees, sir? Till now whatever coding we have done, this is the one where all the things we used here, you know, C programming language, guys. Remember initial days, whatever we have learned as a basic, all these things we used here. Pointer concept, sir. Arrow operator, sir. malloc function, sir. Typecasting, sir. Void pointers, sir. All the things or function concepts, sir. all the things whatever we have learned, almost everything we used here. So this is all about the what is called recursive tree creation and non-recursive tree creation and recursive tree traversal. Recursive tree traversal. Few more functions we are going to incorporate here, right? Search function we will incorporate here. How to search a particular node cell. Not only that, our next target will be another thing, that will be develop the tree recursively, create the tree recursively, right? Currently tree is what? Non-recursively. Create the tree recursively, and next target will be traverse the tree non-recursively. Come on guys, create the tree recursively, traverse the tree non-recursively. That is our next target. So that we are going to see in our next session. And another thing is that, let me complete this one. Wait, sir, 1 minute. Yes, the algorithm for the remaining two, in order and post order. Let me complete that too also. For this, I don't think that, guys, drawing the stack, giving the clarity needed, sir. Because once I've shown it for what is called pre-order traversal. Sir, can you please tell the answer of the tree creation homework? Yes, yes, I will give you the answer. Well, hold on 1 minute, because let me complete this thing first. So this is pre-order. Acha, I hope you will able to manage that in order and post order by drawing this stack. Same tree. Nothing is there, sir. By drawing this stack, giving the numbering to every step, I hope you will able to manage that. It's not issue. Unnecessarily, I'm not going to waste your time by writing those things again. So next is what? So 1 minute. One is for what is this? Recursive algorithm for in order, and another is for post order. Let me do that. Just 2 minutes. Write a recursive algorithm for in order traversal. Input output I will copy later. Let me directly, or same thing, just words will be changed. So this part not required here. The traverse tree in order. Okay. Next, what is the major change? Sir, here this is not the case. So let it be. Don't delete everything, because this fellow will be required. In the middle he will come. Okay. Let me delete this too. That means what? Here in order of PTR arrow L child done in order of PTR arrow R child done. In the middle he will come. Name change, sir. Done. Lastly, Okay, guys. So this is post. Done. Next. This will be what? Post order of PTR arrow L child, right? Then post order of PTR arrow R child. Done. PTR arrow data. Anything else? As a traverse tree in post order. Acha. Dia, sir, can you please tell the answer of the tree creation? No, I will not tell. What you have to do is that whether your answer is correct or not, I will share the coding na today. You will put it here, you will enter it, you will get the answer na. Understanding my statement? You will run this code, you will enter those values, you will go for pre-order, in-order, post-order traversal. If you traverse, because you in that case will go for the traversal one more time, you go for the traversal. If the values are coming, then your tree construction is okay. Understanding? It is in ABCD form. Which one? Homework. Homework means this one. Na? Oh, acha acha. Oh, acha acha. Homework means you are talking about this one, na? 1 minute. Tree construction from both the traversal, na? That is what you are talking about, I think. Yeah, I think you are talking about this two, na? This two. Yeah. Okay. Tomorrow I will tell you. Tomorrow I will tell you the answer of these two. Right? Okay. Yeah. So I will share the class note, guys. The tree coding and the traversal algorithm. Everything I will share. Yeah. Okay. Thank you, guys.